dive into one of the interesting topic in aviation field, that is air breathing engines. Have you ever wondered what powers a jet aircraft? Whether it's commercial airliner cruising over continents, a fighter jet piercing the skies, or a futuristic spaceplane reaching hypersonic speeds, they all rely on air breathing engines.
Today we will explore three main types: turbojet, turbofan, scramjet. Each plays a vital role in aviation, from passengers flight to military and space exploration.
We will break down how they work, their advantages, and where they are used. And stick around for some fascinating did you know facts during our discussion.
Now let's start with the turbojet, the earliest and simplest form of jet propulsion, developed in 1930s and widely used in the mid 20th century. Turbojets were crucial for early jet aircraft. So, what is turbojet engine? A turbojet engine is a jet engine that uses gas turbine to produce thrust by ejecting hot exhaust gases. So, how it is works? The air is intake. The engine pulls air at high speeds in this region. You can see here the air is pulled out by the engine through this diffuser. The air is compressed in the high pressure turbine using axial compressor and increasing pressure and decreasing velocity. The combustion in a combustion chamber, the fuel is injected and ignited, creating high energy gases. This energy is used to propel the aircraft. The turbine stage. The hot gases spin the turbine, which drives the compressor. Exhaust gases. The exhaust gas exists through a nozzle at high velocity, generating thrust. In some of the turbojet engines, here the afterburner is used to generate maximum thrust. The turbojet engine is used in a Concorde aircraft. The Concorde aircraft is a supersonic airliner used in 1986. The Concorde aircraft engine specifications. The engine used in a Concorde aircraft is manufactured by Rolls-Royce. It is a turbojet with afterburner which produce maximum thrust for the Concorde aircraft. The maximum thrust for the Concorde aircraft is 38,050 lbf with afterburner. It has 7-stage low pressure and 7-stage high pressure compressor. It uses jet A1 type of fuel. To talk about the types of inlet used in a turbojet engine. The first type of inlet used in a turbojet engine is a pitot type inlet. It is the most common type of inlet used in a modern aircraft, an air intake system for subsonic and supersonic aircraft engines. The design of the pitot type inlet is axis symmetric, single duct structure with a diffuser section. The working principle for subsonic pitot type inlet is smooth airflow into the engine. For supersonic inlet, it is a shockwave decelerates airflow to subsonic inlets. The performance of the pitot type inlet is high pressure recovery for combustion efficiency, low drag for aerodynamic performance, sensitive to flow distortions. The second type of inlet used in a turbojet engine is a supersonic rams engine. It uses movable rams, so it can pull out maximum air into the engine. The supersonic air intake using angled rams to create oblique shock waves for efficient airflow compression. The design of supersonic rams inlet is series of rams to generate multiple oblique shocks, slows and compresses airflow before entering the engine. Often features variable geometry for different speeds. Working principle. Oblique shock waves progressively slow and compress supersonic air. Final normal shock brings airflow to subsonic before reaching the engine. The performance of subsonic rams inlet is higher pressure recovery than normal shock inlets. It reduces shock losses and improves engine efficiency. It is adjustable rams optimize performance at different Mach numbers.
The turbofan is the dominant engine in aviation today, used in commercial and military transport aircraft. It improves efficiency while reducing noise. What is turbofan engine? A turbofan engine is a jet engine that uses a fan to increase thrust and fuel efficiency. How it works? The fan rotor draws in the air. The air is compressed in the low and high pressure compressors. The injection nozzles create a mix of fuel and air, which is then combusted. The high energy airflow goes into the turbine, causing the turbine blades to rotate. The turbine blades turn the compressor and spin the intake fan. The high-speed air shoots out the back of the engine through the nozzle. The example of turbofan engine is Boeing 787. The engine specification. Manufacturer Rolls-Royce. Type of engine. Rolls-Royce Trent 1000. Maximum thrust. Engine ranges from 53,000 lbf to 75,000 lbf. Compressor stages A stage and 6 stage. A stage intermediate pressure compressor. 6 stage high pressure compressor. Fuel type jet A1. Now we are talking about inlets in turbo. Now we are talking about inlets of turbofan engine. The design of turbofan engine is subsonic inlet. The simple, smooth and diverging duct. No shock wave management required. Optimized for low speed, high efficiency air. The working principle of subsonic inlet slows down incoming air and increases pressure before reaching the engine. Ensures uniform airflow with minimum turbulence. The performance of subsonic inlet. High pressure recovery with low drag. Simple and efficient design for fuel economy. Turbofan engine in supersonic inlet. The design of supersonic inlet uses shock waves to slow and compress incoming airflow. Features oblique and normal shocks for efficient pressure recovery. May have variable geometry for optimized performance at different speeds. The working principle of supersonic inlet. Air enters at supersonic speed. Oblique shocks show and compress it. Finer normal shock reduces airflow to subsonic before entering the engine. The types of supersonic inlet. External compression. Shocks from outside an inlet. Example ramp inlet. Internal compression. Shocks from inside the inlet. Example mixed compression inlet. The performance of supersonic inlet improves pressure recovery and engine efficiency, reduces shock losses and minimizing drag. Turbofan revolutionized air travel, but what if we need to fly even faster beyond supersonic speeds? That is where scramjet come in.
Have you wondered what type of engine we used in missile? The answer is scramjet engine. Our third type of air-breathing engine is a scramjet engine. Supersonic combustion ramjet is an experimental engine designed for hypersonic speeds. The Mach number of a scramjet engine is above 5. What is meant by a scramjet engine? A scramjet engine is a supersonic combustion ramjet engine that uses atmospheric oxygen to combust fuel. How it works? The scramjet engine takes in air at high speed. The air is mixed with fuel. The mixture is ignited to create a thrust. The resulting how exhaust gas propel the vehicle forward. The scramjet engine is used in NASA X-43, which is experimental hypersonic UAV, model number 2004. The engine specification is manufacturer of engine is NASA. The type of engine is hydrogen fueled scramjet engine, and the maximum thrust of engine is 44 to 67 kilonewton, and gaseous hydrogen is a fuel type in this engine. The shockwave compressor inlets is used in scramjet engine. The purpose of shockwave compressor inlets is reduce air velocity and increase pressure for efficient combustion in supersonic and hypersonic engine. Example is ramjet, scramjet, and turbojet engine. There are three types of shockwave compressor inlets. External compressor inlets. Shockwaves form outside the inlets used in fixed geometry inlets. Early supersonic aircrafts. Internal compressor inlets. Shockwaves from inside the inlets can cause flow separation if not managed properly. Mixed compressor inlets. Shockwaves form both inside and outside inlet used in variable geometry inlets for efficient performance at different speed. Example is SR-71 Blackbird. Working principle. Supersonic airflow encounters oblique shockwaves to slow down further compressor. Normal shockwave form near the inlet throats, reducing airflow. The two supersonic speeds for turbojet and ramjet engine. High pressure air delivered efficiently to the engine for combustion.
Now that we have covered all three air-breathing engines, turbojets, turbofans and scramjets, let's compare them. What do you think is the most important engine in aviation today?
I say the turbofan. It is the most fuel efficient, quiet, and widely used engine today. Almost every commercial airline uses it. Without it, modern aviation would not be the same.
True, but if we are talking about pure speed, then turbojet will have still have an edge. Fighter jets like F-22 Raptor use them to reach supersonic speeds, and let's not forget the Concorde, which flew at Mach number 2.
That's a good point. But looking ahead, scramjet might be the future. Imagine if a flight from New York to Tokyo under 2 hours. Which engine is the most revolutionary?
I agree that turbofans realized commercial travel before them. Early jet engines were too noisy and inefficient for long, huge flight. Turbofans made flying cheaper and more accessible.
But turbojet is the first real game changer. They took us from propeller-driven aircraft to supersonic speeds.
And scramjets could revolutionize space travel, reducing the cost of launching spacecrafts. Did you know that the Concorde's turbojet engine allowed it to cross the Atlantic in 3.5 hours?
Here's something cool. The world's largest turbofan, the GE19, has fan blades that are wider than the fuselage of a Boeing 737.
And did you know NASA's X-43 scramjet holds the record for the fastest air-breathing flight ever, Mach 9.6?
What are the future possibilities?
Where do you see air-breathing engines going in the future?
The turbofans will keep improving. New engines like the Rolls-Royce Ultrafan promise 25% more efficiency, which is great for reducing emissions.
But scramjets could refine travel. Imagine skipping long haul flights and reaching any destination in an hour.
There's even talk of combining turbofans and scramjets. An aircraft could take off on turbofan and switching to a scramjet at hypersonic speeds. I have a final question for you both. Which engine do you prefer?
I pick turbofans. They are efficient, reliable, and power everything from passengers, planes to military transport.
I still prefer turbojets for their raw power and speed. Without them, we wouldn't have supersonic flight.
I will go with scramjets because scramjet is the future. It is a hypersonic engine. So scramjet could take us to space and even easier to travel. Each of these engines, turbojets, turbofans and scramjets plays a vital role in aviation.
From commercial and travel of military, jets are and even space exploration, air breathing engines continue to push the limits of speed and efficiency.
And who knows, maybe in the near future we will be flying in hypersonic scramjets, powered planes.
That's a wrap up our discussion. Thanks for joining me.